Hello students, how are you all? I hope you are enthusiastic for today's lesson. It is the first lesson, so let's begin with the chapter first. Chapter 1 is of primes, highest common factor and the lowest common multiple. Section 1.1 is of prime numbers. Section 1.2 is square roots and cube roots. Section 1.3, highest common factor and the lowest common multiple. And at the end, you will challenge yourself. So let's begin with the chapter number 1, section 1.1, prime numbers. Prime numbers. Prime number is a whole number that has exactly two different factors, 1 and the number itself. For example, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, and so on. A prime number is a whole number, so it means if the number is a decimal number, you are not going to consider it as a whole number, and you will not consider it as a prime number. Prime number are only whole numbers. Whole number means that there are no decimals in the number. Now, a prime number is a whole number that has exactly two different factors, the number one and the number itself. It means that all these prime numbers are all having only two factors. Either they are divisible by the number 1 or they are divisible by the number itself. For example, number 2 is only divisible by the number 1 and the number 2 itself. Similarly, the number 11 is only divisible by the number 1 and the number 11 itself, and so on all the other numbers. Let's give an important information here that the number 2 is the only prime number which is also even. All other prime numbers are odd. So you will get the idea from all these prime numbers, so on, and you will see that there will be no even numbers in the prime numbers except this, the number 2. Now, whereas the composite number is a whole number that has more than two different factors. A composite number has a finite number of factors. Now, those numbers which are not prime numbers, they are the composite numbers. So, for composite number, they are also whole numbers, but they are having more than two different factors. For example, if we have the number 4, 4 is divisible by the number 1, the number 2, as 2 2s are 4, and the number 4, 4 1s are 4. So it means that the number 4 has 3 factors. Similarly, if we go for the number 6, it is divisible by 1, it is divisible by 2, by 3, by 6. So it means it has 4 possible factors. Similarly, for the other numbers, you can also check the factors. Let's suppose we talk about the number 12. The number 12 is divided by the number 1, number 2, number 3, number 4, number 6, and number 12. So 12 has almost 6 factors. Similarly, all those numbers and all those specifically even numbers or sometimes odd numbers, they are all composite numbers if their factors are more than 2. Let's go on. Prime and composite numbers. Since 0 has infinite number of factors, we don't know how many factors of the 0 are. 0, 0, 0, 0, 0, 0. So it is neither a prime nor a composite numbers. Since 1 has exactly one factor, 1 has no other factor. So it is also not a prime number nor a composite number. It is a very basic misconception that some of the students, they always consider 1 as a prime number, but 1 and 0, they both are neither prime numbers nor composite numbers. Again, remind the fact that 2 is the only prime number which is even. All other prime numbers are odd. Move on. Go for other investigation. The smallest prime number is 2. The largest prime numbers less than or equal to 100 is 97. 98, 99, and 100, they are all composite numbers. So the biggest number under 100 is 97, which is a prime number. There are 25 prime numbers which are less than or equal to 100. So if you want to count how many prime numbers are there in between 100 and 1, from 1 to 100, there are 25 prime numbers. Not every odd number is a prime number. This is a very basic misconception. For example, the number 9. It is an odd number. It is not an even number, but it is not a prime number. It is a composite number. Why? Because 9 is divided by the number 1, the number 3, and the number 9. So it has more factors other than number 1 and number itself. So 9 is not a prime number. It is a composite number. Not every even number is a composite number. This is also a misconception, just because we know that the number 0 and the number 2, they both are even numbers, but they are neither prime nor composite. For a number greater than 5, if its last digits are 0, 2, 4, 6, or 8, then the number is a multiple of 2. Or, in other words, we can say all the even numbers, they are the composite numbers other than 0 and 2. If its last digit is 0 or 5, then the number is a multiple of 5, thus it is a composite number. Hence, for a prime number greater than 5, its last digit can be only 1, 3, 7, or 9. So whenever you are going through a bigger number and you want to check that whether the number is a prime number, just go for and check the last digit of the number is either 1, 3, 7, or 9. If it is 1, 3, 7, 9, then it might be a prime number, but it is again not necessarily say that this is a prime number. Now there is an activity. All of you are supposed to tell me, can the product of two prime numbers be an odd number? I'm giving you only one chance. Yes, the product of two prime numbers can be an odd number. For example, the product of two prime numbers, 3 and 5, is the odd number 15. So when we talk about two prime numbers and we multiply 3 and 5, they both are prime numbers, and when we multiply, it's again an odd number, 315, but it is not a prime number. Second question, can the product of two prime numbers be an even number? Think about it. Yes, the product of two prime numbers can be an even number. For example, the product of the two prime numbers, 2 and 3. 2 and 3, they both are prime numbers. When we multiply them, when we take the product of these 2 and 3, we get the number 6, which is an even number, and it is formed by the product of two prime numbers. Can the product of two prime numbers be a prime number? Think about it. No, the product of two prime numbers can never be a prime number, since when we multiply p1 and p2, they has at least three intact factors, for example 1, p1 and p1, p2. So it means whenever we multiply two prime numbers, the answer will not be a prime number. Interesting facts about prime numbers. The 1 millionth prime number is 1548583. The last digit of the largest ever known prime number is 1. Now, for your exercise and practice, you have to do these questions. Determine whether each is a prime and composite number. This is from the book D1. Questions are 87, 67, 73, and 91. Just look at them and solve them in a separate register or in a separate soft copy or in a proper folder. Then there is a worked example, page number 6. Determine whether the prime or composite 387 and 47. Then practice now on page 6. Are 537 and 59 prime or composite numbers? This is all from today's lesson. I hope you have enjoyed prime numbers, and now you would be able to implement the concept of prime numbers throughout, and you will never be forgotten with this concept, and you will apply this concept wherever it is needed. Take care, and we will be sharing this exercise and practice solution in the next coming slide. Take care. Bye-bye.